per 1. So normally the sequence for all the questions, they will arrange from Form 4 up to Form 5 according to the subtopic as well. So let's look at first questions. Which of the following physical quantity match with the correct SI unit? So basically, physical quantity is any quantity that can be measured by scientific instrument. So example, time, mass, length, force, density, and so on. Okay, so for these questions, you need to know what is their SI unit. So for time, basically the SI unit is second. Then mass, kilogram, length is meter, and force is actually Newton. So among all four options, the answer for B is the correct answer. So this question is from Form 4, Chapter 1, Measurement 1.1. Okay, we proceed to questions 2. Questions 2 is from Form 4, Chapter 2, Forces and Motion 2.2, Linear Motion Graph. So based on the diagram, it shows a displacement time graph of a car moving in a straight line. So which of the following velocity time graph represent the motion of the car? So for these questions, how do you solve the questions is basically you need to relate. How do you get velocity from displacement time graph? So basically we can get the gradient. As gradient of the graph is displacement over time, which is equivalent to the idea of velocity. So due to this idea, okay, we're going to get the instant point and find out their gradient. Okay, so you can do this way, assuming teacher take 1 point from here and then about 1 point from here. So then you'll draw the tangent line. You'll notice that what happened to the gradient of the graph. Okay, I assume this is a point A, point B. So B is less steep. If B is less steep, which means the velocity actually decreases until it stop at this horizontal point, right? At this moment, time equals to 25 seconds, right? Actually, the object stop. Then what does the downhill motion move means? It means the object actually move in opposite direction. So if I were to show in the line graph, it will be a better idea for you all to get the concept. So it means when this object car move from 0 second to 25 when the t time assuming teacher give length also lah. So let's say that travel track 10 meter. So this is 10 meter. Okay, so this is the displacement. So upon downhill idea, which means this part, they go downhill, right? Which means it will move backwards. Then back to 0 meter. Notice? Okay, so this is the idea on the displacement time graph. Whenever you're not sure, you can always use line graph to draw the idea. So same thing, you will actually put 2 dots, and then you try to figure out what happened to the velocity now. So it will be decreasing first, then increasing, right? The gradient. Yeah, so therefore it's getting faster in terms of velocity. V is increasing then when they are moved in opposite directions. Okay, so based on this graph, the velocity will decreases first until it stops. Okay, so the possible idea will be A, C, and D for the first part. But this part memang is wrong. Then moving on to the next idea will be because the object now move in opposite direction. If the object move in opposite directions, so the velocity is actually negative. Negative. If it is negative, therefore it will be below the graph instead of above the graph. So therefore, your answer is actually B. And if you notice, from this point onwards, the velocity actually increasing, but in opposite direction, in negative. So the negative have two meanings lah in forces and motion in a vector quantity idea. Okay, it can be referred to the other directions, or it can also means decelerations if you all were to have acceleration time graph. Okay, then we move on to the next questions. So for question 3, it is from chapter 2 on the topic for inertia. So which of the following show effect of inertia? What is the meaning of inertia? Inertia means the tendency of an object to resist change in motion, or it means if the object want to remain at rest, it will be in the state of rest. If they are at motion, they will continue in motion in a straight line. Motion, then they will move in straight line. So this is the idea of inertia. That means they do not want to change its state. So the first case is the idea of inertia, because the coin have the tendency to remain at rest. So if you were to pull the paper fast enough, the coin will drop due to gravity. Then number 2, why this guy will actually thrown forward when it move and not some obstacle because now he is in motion, so that's why he have the tendency to keep on moving. That's why when there is some obstacle, stop the bicycle, but he still have the tendency to move forward. That's why he thrown forward. So this is also the inertia idea. Number three, not related to the idea of inertia. You just pressing the thumbtack. So it's relating to the idea of force. And if you were to see the surface area, then they will relate to the idea of pressure lah. Smaller area, higher force. So therefore, the answer is 1 and 2. And the answer is A lah. Okay, then move on. We have questions 4. Diagram 2 show 3 identical coins, P, Q, and R at rest at a horizontal surface. What happens if P is pushed and collide with Q? Okay, so this idea is under the concept of principle of conservation of momentum. Okay, general idea, what is momentum? Momentum is P equals to mv, where any object have mass, they will have velocity. So initially when P is moving, does P have momentum? Yes, the P have momentum mv, but Q is stationary. So the moment P have knock Q, what happen is it will transfer its momentum to Q. But at the same time, because beside Q there is another item R, so Q will also transfer its momentum to R. So hence, what will be observed here is lastly, because the total momentum have been transferred to object R, therefore P and Q will remain at rest. Okay, so these two will be at rest or stationary lah, while R finally will receive the momentum mass, so that's why it will move. Okay, so it will move. Therefore, which is the proper answer from the option? Like I mentioned, okay, you will have the answer as stationary move. So it's B. Okay, then we proceed to number 5. Which of the following system will give the greatest acceleration on an object of mass m? So this is from Form 4, Chapter 2, force. So the idea, they want to have greatest acceleration. So for this topic, 2.6, the idea of force. So you will have the concept F net equals to ma, Newton's second law of motion. You want the greatest acceleration, hence your resultant force or net force must be the greatest. Okay, so among these 4 options, and force is a vector quantity, so direction is important. If they were to in opposite direction, then you have to denote one of the direction as negative. negative. So for A, what is the net force? Okay, because they're in opposite direction, so you can assume that this direction is positive, this is negative. So hence you will get 50 plus negative 60. You will get negative 10, right? So this negative also mean to the left. Okay, so this is the idea on how you calculate the resultant force. So for A, your resultant force is 10 Newton to this direction. So how about B? B now is same direction, right? So you can still assume on both is on positive. So that's why you have positive 25. Then the positive mean toward right side. Then for this one, again now you see opposite direction. So therefore the net force is 5 Newton to the other way. And lastly, this will be 45 Newton. So that's why among all four options, the greatest force is this. So the answer will be D. Then number 6. Number 6 is idea under the topic for 2.7, impulse and impulsive force, still under the same chapter, forces and motion. So you notice there's quite a number of questions because chapter 2 from 4, they have 8 subtopic. So that's why the questions also more. So diagram 3 show an athlete bending his leg upon landing in the long jump event. The athlete bends his leg to reduce what? To reduce. Okay, so what is the idea on this topic? Is regarding impulsive force. So what is impulsive force? Impulsive force, F equals to the rate of change of momentum, mv minus mu over t. Okay, so based on the equation, either the force is directly proportional to change in momentum, mv minus mu, or the force can be inversely proportional to the time of impact. That means the moment, the time you touch the surface of an object. So based on this context, you bend the leg because you actually want to lengthen the time. What is the purpose of lengthening the time? Because you want to reduce the effect of impulsive force acted. So in this case, they want you to give the idea to reduce what? Like I mentioned just now. So the answer will be impulsive force on his feet. On his feet. So your answer will be B. Okay, now moving on to question 7. Question 7 will be under the idea of chapter 3, gravitations. So the first one is on this 3.1. What is the reason for the motion of the moon on its orbit? Okay, so as you all know, Earth is a bigger mass of object compared to the moon, right? So the questions here is saying that why the moon keep on orbiting the Earth. So this is the idea. Okay, so because there is the force exists, right, between the two objects, and the force on this Earth is much larger due to the Earth have larger mass. The mass is larger for the Earth. Therefore, the pull is also greater, and hence your answer will be there is a gravitational force exerts on the moon by the Earth. The Earth pull the moon. The Earth pull the moon. The centripetal force idea also. Then moving on. This is still under the chapter 3 on Kepler's law. The period of satellite in a circular orbit of radius r is t. Then the period of another satellite in the circular orbit of radius is 4r. Okay, so what Kepler's third law state that Kepler's third law state that okay, the square of the periods is actually directly proportional to the cube of the radius of orbiter. radius of orbiter. And based on the calculations, is saying that this T1 square over R1 cube is equals to T2 square over R2 cube. So we're going to use this idea to solve the questions. Okay, so the concept for Kepler's law, basically, if you were to have Earth, same thing, you have a different planet that orbiting. Okay, this is planet 1. Then you can also have another planets orbiting, planet 2. So the ratio of T1 square over R1 cube is the same as T2 square over R2 cube. So which means if your radius, you see for the object 1, their radius is R, right? Then for object 2, the radius is now 4. Okay, so if you are getting further from the Earth, which means your period is also getting longer. Okay, so how do you solve these questions? Okay, you need to make use of this formula. Okay, so assuming now we write aside your T1 is T for this context, while your R1 is capital R. Then they want you to find what? T2, question mark, you do know unknown. And your R2 is basically for R. Okay, so now we're going to sub into this equation. So hence, teacher will have what? T square over R cube equals to T2 square over R bracket cube. Careful, must bracket. And I want T2, so I rearrange first. My T2 square become what? T square over R cube, I cancel out by bring to the other side, right? So time 4 cube is 64 R cube, and I can cancel off my R cube. Okay, and therefore T2 square equals to 64 T square. And I want T2 so you square root. So finally you get what? 8T. So your answer is basically A lah. And if no problem, then we proceed again to the next questions. Then now, question 9, we're entering the new chapter, which is chapter 4, heat 4.1. This one is on thermal equilibrium. Two objects are said to be in thermal equilibrium. So what is the meaning of thermal equilibrium? Okay, thermal equilibrium means when two objects, a hot object, in contact with a cold object, they must be in contact lah. Two objects with different temperature, they're in contact first. Then they will reach what? A thermal equilibrium when both objects have what? Okay, same temperature, or they will have same temperature. And another key idea is there is no net flow of heat between the two objects. Okay, so we see the options. Okay, they will have same mass. No, they will have the same temperature. Yes, they have the same heat capacity. Also, no. Same amount heat energy. So the correct answer is D. Moving on, we have number 10. Number 10 is still under the idea for heat. You have this specific heat capacity concept. So diagram 4 shows solid block A and B of equal mass are being heated. And the initial temperature of A and B is the same as they are heated by the same amount of energy. And it's observed that A is hotter faster than B. This observation is due to the difference in what? So that means they say A is hotter. If hotter, that means the temperature is higher. This one compared to this one, we assume the temperature is lower lah. Okay, cooler. So Therefore, this idea is on specific heat capacity. What is actually specific heat capacity? Specific capacity is the amount of heat energy needed to increase the temperature of 1 kg of substance by 1 degree Celsius. Okay, so if the object heat up faster, that means they just need to absorb a small amount of heat, then the temperature will increase already. So basically A and B, they are supplied with the same amount of heat. So I show you the idea basically. So assuming block A have 100 joule per kilogram per degree Celsius, while B have 1000 assumption. So all this value is specific heat capacity, and they are actually a constant. All materials have their own specific capacity. So you see, like object A, the object A, they absorb 100 joule, they already can increase 1 degree Celsius. But for object B, they have to absorb 1000 joule, then only they can increase 1 degree Celsius. So this is the meaning. So that's why it's also showing that A have smaller specific capacity lah. So your answer is C. Then we proceed to the next one. So which of the graph is related to Gay-Lussac law? Okay, so yeah, I used to tell students how do you remember all the 3 gas law by just using a simple triangle. Okay, then you draw this triangle and then you label the quantity P, V, T. And the 3 sideway will be the 3 respective law. Guru Bahasa Cina. So Gay-Lussac law is really related with P and T lah. Then next idea, you all need to get the concept of what is the relationship between temperature and also pressure. When you heat up something, what happens to the pressure? Okay, of course, there are increases, right? So Gay-Lussac law state that pressure is directly proportional to temperature. And this temperature must be absolute temperature, which is in Kelvin, in Kelvin. Okay, so therefore, which graph showing P and T directly proportional and in Kelvin? The answer would be D. Because this is wrong, provided this temperature is in degrees Celsius and this is inversely proportional, so not acceptable. And this one is decreases linearly, okay? Also, they are not correct. Okay, question 12 is in Form 4, Chapter 5, Wave 5.2, Damping and Resonance Idea. Diagram 5 shows a load tied to a spring which oscillates vertically in the water. And which of the following displacement time graph show the oscillations of the load? So when the load is placed inside the water and being oscillated, the idea behind is they will encounter water resistance. So when the load encounter water resistance, whereby they will oscillate, they will start to encounter damping. So what is mean by damping? Damping is decrease in amplitude due to loss of energy. So based on the options, C and D is not acceptable as amplitude remain constant. Okay, whereby this amplitude is actually from the equilibrium position to the press, or they can also from the equilibrium position to the trough lah. So this is the idea of amplitude. A and B showing that the amplitude is decreases. But which one is the best choice? So the best choice, basically, we need to look into the period as well. So period is what? Period is the time to complete one oscillation. So if you were to start here, you're supposed to end on the next crest. Okay. So you all look at the distance. And also what means they give you the boxes like that, right? So like this one, they take 4 parts or 4 boxes to complete one oscillation. Similarly, this one also say 4. Okay, so I remove the arrow, I show you again. Okay, 1, 2, 3, 4. So this is one complete oscillation. 1, 2, 3, 4. So period remain constant. So that's why the answer is B. Okay, for 13, is still under the wave topic. 5.3 regarding refractions of, reflections of wave. So which statement is correct when water waves are reflected by a reflector? Okay, so most of the time when they ask about the phenomenon of wave like reflections, refraction, diffraction, they always will ask what is changed, what is not changed after those phenomena. So basically for the reflections of wave, again, this is the few quantity that they always ask: frequency, wavelength, speed, and also direction. So for reflections and also diffractions, basically, frequency doesn't change, wavelength doesn't change, speed doesn't change. They only change in direction. So that's why the correct answer will be A, because frequency and wavelength changes for B and C. Then number 14. 14 is underway for refraction now. Okay, so for refraction, based on just now the characteristics, similarly, you have frequency, wavelength, speed, and direction, right? Okay, so for refractions, only frequency doesn't change, but wavelength, speed, and direction will change. So in general idea, if I show you all 2D, it will be more easy to get the or capture the idea. So this is the region, let's say you have water, right? So this is the region where we call it as shallow region. And then this is the region of deep region. Okay, so the water wave will travel from left to the right. Okay, so when this occurs, what happened to the water wave? So they will be entering shallow that time, right? They were getting this way. So still remember what is wavelength? Wavelength is the distance between 2 consecutive points which are in phase. Okay, so if you were to observe the wavelength lambda 1 compared to the wavelength when they are in the shallow region lambda 2, they're actually getting shorter. Shorter, which means the speed also decreases as V equals to F lambda, frequency is constant. That's why you have the relationship. Okay, when shallow region, they are decreased in wavelength. So based on the diagram, okay, wavelength is here now. Lambda 1, lambda 2. So lambda 1 is shorter than lambda 2, right? Which means at this region, they're supposed to be shallower or at P. Okay, so we see which is the correct answer, or the other way around means Q is deeper. So region P is deeper, wrong. Region Q is deeper, correct. Okay, both have uniform depth, no, because they're really different in depth. And the speed of P is greater, no, B by right is a shorter wavelength. So that's why the speed is slower. Okay. Then for question 15. 15 is under the topic 5.6, interference of wave. So it's also type of phenomenon. But for this one, they involve calculation questions. So diagram 7 show an interference pattern produced by two sources of wave, water wave. If the wavelength is 1 cm wavelength lambda, then what is the value of A, the distance between the two sources? Okay, so basically for interference of wave, you all really need to know the formula, which is lambda equals to AX over D. And of course, you all need to know what is this AXD refer to. Lambda is wavelength. So A is the distance between two sources as shown in this diagram. And what is actually D? D is the distance from the source to the screen, whereby they already show you D. And what is actually this X refer to? This X refer to distance between two consecutive nodal line or anti-nodal line, or sometimes anti-node and anti-node also can. So what is this nodal line? This nodal line is constructed due to destructive interference. Destructive interference, while anti-node refer to constructive interference. Constructive interference. And when do we form in destructive interference? Destructive only one condition, where when crest meet with trough produce zero amplitude. While for constructive, you may have two ideas, whereby you have crest meet with crest or trough meet with trough, and the end result is they will have maximum amplitude. Okay, so let's see the graph here. So the water wave is actually the one that you see clearly, right? Is actually referred to crest. And then the dotted line is referred to trough. The dotted line. Okay, so let's see, this point is what? Crest and crest, right? That means constructive. This is also constructive. How about this one? Also same, right? Constructive point. So that means this is what line? These two both is antinodal. This is also antinodal. Antinodal. How about the center one? It's also from crest and crest, or trough and trough and crest and crest. It also refers to antinodal line. But just now I explained already what is X. X is distance between two consecutive, that means next to each other. So your X is over here only. X is over here. So therefore your X is half from the 5 cm, and therefore you get 2.5. Until you get all these, then only you can sub into the equation again. Before you sub for this interference formula, most of the time they may also trick you by having different unit. But in these questions, because they test you the idea of this X, so therefore you see the unit, they are all in cm. So no worry, you can straight away sub every value inside. Okay, so therefore from the formula, then we have lambda equals to ax over d, right? We rearrange a equals to lambda d over x, and you will have lambda as 1, d as 7, x is 2.5. And you press calculator, you will get 2.8 cm. So that's why if you are not aware about this idea, what is x, the idea of two consecutive antinodal line, then you may straight away sub, then you may get the wrong answer. So be careful when you all apply this formula. Sometimes they can be direct, sometimes you need to look in detail a bit. Okay, then moving on, we have question 16. Question 16 is still under the wave topic, but on electromagnetic wave. So which of the following is the property of electromagnetic wave? So as you all know that you can classify wave in transverse and longitudinal, and all electromagnetic wave, they are actually transverse waves, and they are basically able to travel in vacuum. They can travel in vacuum with the speed of light 3 × 10⁸ meters per second. And they're able to be polarized. So what is mean by polarized? So it's some sort the polarizer, like the how they actually use to actually block part of the light. So they have the property where the polarize, they can have the vertical, and also you can rearrange them into a horizontal position. So let's say you have full light traveling and pass through the polarizer. Okay, so when they filter, right, so the vertical one actually not there. some sort like that lah, huh? So it's like you block part of the light, and then you even pass through the particle, then there will be no light lah, some sort. Okay. So it's just like your uh the, how to say, shade, the idea like shade like that. So that's why this is also their property. B is wrong lah, because it's transverse ma, and then I mentioned that can travel through vacuum. So the answer is A. Okay, next we have the next last topic in Form 4, which is Chapter 6, Light and Optics. So 6.1 is on the topic for refraction of light. Okay, so for reflection of light, okay, you all need to know the idea of what refractive index. There is 3 ways to find the refractive index, whereby you use what, n equals to psi I over psi r, or also you can have speed of light in vacuum over speed of light in medium, or even you can have the idea of this real depth over apparent depth. Okay, but in this question we are focused on this because they give you angle. So for refraction to occur, the ray must travel from less than medium, which is air, to denser medium, okay, which is glass, or vice versa. That means you can also travel from glass to air. So in this case, if you travel from air to glass, the ray will slow down. So when they slow down, they will actually refract towards normal line. So this is normal line. Okay. Okay, then next idea, you'll need to know where do you locate the incident angle and also refracted angle. So for these questions, your incident angle is the angle between the normal line and the incident ray. So this ray is incident ray. So this I lah. And refracted angle is the angle between the refracted ray with normal line. Okay. So for you to get the idea of X, you need to find out what is incident angle first. Okay, and then given questions that say what? The ray passing through in a glass block and the refractive index is 1.52. So this is referred to N. They want you to find X. So like I mentioned, you need to find what is I first. Okay, then only you can get X. But do you have R? Yes, you have N. So same, you rearrange the formula and then get the angle for I first. So psi I equals to what? N times psi R, which is 1.52 multiplied with sine 35. Okay. 1.52 times sine 35. And you by right get 0.8718 lah. But I want I, not sine I. So how do you get I? You press calculator, shift sign, answer. And you will get 60.67 degree. But like I mentioned, are you finding I? No, you want to find X. Okay, so basically this whole part is how many degree? You all learn in maths, what, 90 degree, right? So to obtain X, I need to use 90 minus 60.67 and I get the answer. Okay, so same thing for this question. If you not aware where is the actual location of incident angle or refracted angle, then you may not be able to find the answer. Okay, and another thing to be take note is if the ray travel from denser to less than medium, because light ray can be reversible, means you can be the other direction like this. So when you calculated the answer using the formula refractive index, right, you have to inverse the angle as well, which means you will become N equals to sine R over sine I. Or simple, I always tell students, you remember the angle on top is always bigger angle. Below is smaller angle. Okay. What means this formula is only true if the ray travel from less than to denser lah. If the other way around, you reverse the formula. Okay. Then moving on, we have questions 18. Question 18 is under chapter 6, 6.2, total internal reflections. Diagram 9 show a light rays traveling through an optical fiber. The optical fiber has a glass core X of refractive index and X and a glass cladding Y of refractive index and Y. So this NY is the outer one, okay, and X is the inner core. Okay, so for total internal reflections to occur, they have two criteria. One, the ray must travel from what? Ray travel from denser medium to less than medium. Then next idea will be the critical angle is more than the incident angle. So optical fiber is one of the applications that apply this total internal reflection. And there are two functions for optical fiber lah. One is actually used as endoscope. That means they can have camera that have, it's just a very fine strand of glass. So they can insert into the body and then check what happened to your internal organ used in medical line lah. Or they actually use as the communication line, which is internet nowadays, yeah, so they make use of optical fiber. Okay, so therefore, for the ray to have total internal reflection, like this diagram, right, where is the total internal reflections idea? So the ray will actually keep on reflected inside the medium. So this is a point, I put arrow one, where total internal reflection occur, short form. So all these points. So why they're able to have the idea show, like I say, the inner, they have to be denser. Then the outer core, less than medium. Okay, then next idea, how do we link the density with the refractive index? So if the medium is denser, their refractive index also higher. If less than, then they'll be lower, which means in this context, your X should be higher, Y should be lower. Okay, equal cannot, no? So the idea will be in B already. C the other way around. Okay, and basically for your understanding, refractive index cannot less than 1 because 1 is actually no change in medium, like air to air. So that's why like just now I mentioned on previous questions as well, on refractions, right? Whenever you use the n equal to sine r or sine r, it's only true when it travels from less than medium to denser. If the other way around, you have to inverse the formula, or else you will get the answer less than 1 for refractive index. Then for questions 19 is on the image formations for lenses. Okay, diagram 10 show an object which is placed at U from the center of a convex lens. The focal length of the lens is 30 cm. So which of the following characteristic of the image is correct if U is at 25 cm, 40 and 60 and also 70. Okay, this one wrong, typo. Okay, so for you to solve this question, first you really need to know well about how to draw the ray diagram for convex lens. Or if you are my student, I always will guide through student to memorize a simple idea regarding 6-ray diagram for convex lens when the object is at different position. So a simple idea, I show back the concept first. You would to have a lens. So basically, when the object at different point, okay, so all lenses they will actually have their focus point. Okay, So focus point is a point where all the ray parallel to the principal axis, they will focus lah. Okay, so this is focus point. So this is double focus point. So for when you all draw ray diagram, right, the object can be located at different point. Means your object can be less than focal length. So where is the object distance? For understanding, object distance is from center to the object lah. This is object distance. So like this is called less than focal length. And also your object can be at focus point. Then they will have different final characteristic of image form, or between F and 2F, and then F double F, or more than 2F, or at last they can be infinity. Okay, so based on this idea, right, I just show up lah. Let's say between F and 2F, not necessary at the center. That's mean in the region, as long as they're in between. Until they also may have one more condition called infinity. So I always tell students this is the 6 ray diagram that you have to master, draw, and remember their characteristic. So this is case 1, 2, 3, 4, 5, and 6. And there is a rhythm one called boom, boom, rim, raise, rit, rit. V stand for virtual, U stand for upright, M stand for magnify. Okay, same go for the second one. Then R stand for what? Real. I stand for inverted. D stand for diminished, smaller, diminish. And S stand for same size lah. Okay, so this is the rules that I always ask students to remember. Okay, if you didn't draw the ray diagram out like these questions, you can still able to identify the characteristic of the image form. Okay, because while you would to draw for 4 condition is a bit time consuming, right? Okay, so for this context, okay, they say that the object can be at 25 cm, 40, 60, or 70. And you need to know where is the focal length. So the focal length is 30 cm. Okay, so we assume that the object can have 4 position. So that's why I don't want to confuse you. So I don't show the object first. I don't show the object first. Okay, so which means this is the focus point. And the length here is how many cm? 30 cm. This is focus point. That means 2F is how many cm? Times 2, right? Okay, so this is 2F. That means here to here will be 60 cm in total lah. Okay, so if it is 25 cm, can you all tell teacher where is the object based on what I label? So of course, your object will be on which case? Case 1 or then 40 is where? 40 is here lah, in between. I didn't draw to the actual scale lah, but what means is the locations. Okay. Okay, how do you measure again? From where to where is the object distance? Here to here. Okay, by right, 25 cm here more proper lah, but as long as it's less than focus point. Okay, get it? You are the distance for you. So then 60 is where? 60 cm is exactly here already, which is which case? They are case. But by the way, if 40 cm, then they are in between, right? In between is case 3. Then 60 is case 4, exactly at focal, double focal point. And lastly, 70 cm more than that, right? But not infinity yet. Infinity means very, very far away. So they are case 5. Then you just write, if you remember this rhythm, boom, boom, rim, wrist, rit, rit. So this one is boom, then this is actually rim, and this wrist, and then this rit. So then you counter check, Is the idea correct or not? Virtual, bigger. Okay, correct. Virtual, no. Smaller, also no. Real, correct, but bigger, wrong. Okay, then real, correct, but then bigger, also wrong. So the answer is A. Yeah, it seems like, wow, kind of hard, but then if you understand the rules, then it will be easy. It will also apply in the idea of mirror as well, but it's for concave mirror. So I hope that the explanation for this not only apply for these questions alone. So I have been explaining a lot regarding this. Hopefully it's helpful to all of you. Okay, so then we move on to the next questions. So for question 20, diagram 11 shows the image form on the screen is blurred. Which modifications will produce a sharp image on the screen? Okay, so you want the sharp image. Sharp image means the final image where the intersection point, this is when the image is formed. So by right, your screen is over here, then only the image form is sharp. So, but now they are not formed on the screen. What can you modify so that it can form on the screen? Okay, for the idea of construction of ray diagram, okay, indeed, you must always have the object and optical center, right? You will have the ray strike and touch the screen. So another idea is you can have the ray parallel and then cut through focus point and join. So I would do from here, cut over here and parallel. I do the reversal by right. You're supposed to be parallel cut through focus point. So if the focus point, it would to be longer, further, then your final image will be located here, whereby you will have a sharp image form on the screen. So let's see any idea regarding focal length here now. Replace the length with a convex lens of longer focal length. Yes, this is what we want. Shorter, no. Okay, unless your image is out from the screen, then you need the reverse. Then you move the object further. So if you move the object further, you should know what is the relationship between object distance and image distance. Okay, so for the idea in lens formula also, they got mentioned when your object distance increases, image distance should be decreases. So you move further, that means your image distance is even shorter, right? So it's not applicable unless you move the object nearer. Yes. And lastly, move the object until it is at focal point. No. So because when the object is at focus point, by right, the image form is at infinity. So the answer is A. Okay, moving on, we have questions 21. Okay, so this is the object in front of a concave mirror. So which is the correct image? So for you to know where is the location, then you need to draw the ray diagram. So this is the last subtopic for like topic, the image formation formed by a curved mirror. So same thing, to construct ray diagram, you always start from the object head. Parallel, touch the mirror, right? So because this is mirror, if it is mirror, what is the phenomenon occur? Reflections. If it is reflection, that means the ray will actually touch the screen, then they will strike already, and then they will bounce. They won't pass through one. Get the idea? So they will bounce and cut through where? Focus point. Okay, then another ray diagram that you can form, a ray that you can form for the mirror is you actually strike to focus point and then parallel out. So actually we have the answer already. Notice or not, the intersection point between the red and the blue color is where the image forms. So where is it? So the answer is C. Okay, or you can have one more ray diagram. The ray that used for the formation of image is from object head, you cut through the center of curvature point Q is actually C, double F. Okay, center of curvature. Normally we use the term C or 2F. Okay, so you can actually just draw it and cut it. And of course, at the same time, you're supposed to, from the mirror, you strike back lah. Okay, so the mirror here is just a representation. You can make it like longer. So they strike and then they bounce back. So that's why all the three rays is actually intersect at the same point. So this is how you all draw ray diagram for mirror. Okay. Now we move on to the Form 5 topic. So for objective questions, they are altogether 40. You see the allocation of questions for each form, right, is more or less half like that. So now we entering Form 5 topic already for questions 22. Diagram 13 show an object is at rest on a rough inclined plane. Which relationship is correct? Okay, so for Form 5 topic under the concept for forces and motion, right? The first three topic, they always have the question which is interrelated. So if you're not sure on 1.1, you actually kind of hard to get the idea of 1.2 and so on for 1.3. So like this question, you need to know the concept. How do you resolve force? Then you apply the idea of forces in equilibrium, which is 1.3. Okay, so the keyword for these questions, you all need to be alert. One is, first, the object is at rest. So if the object is at rest, that means what is the resultant force act on the object? 0, 0 Newton. Okay, then this is the idea of equilibrium. This is the concept of equilibrium. Okay, then next, you're going to resolve weight for inclined plane. So giving your force, which is weight, you can resolve it into two components, which is a component that parallel to the plane, and also another component which is perpendicular to the plane. Okay, I always name them as FP lah. You can have any other representation, but then this is, I always call it as FM. And the angle on this inclined plane theta, they're always located over here, theta. Okay, and again, I teach students a way of how do you know whether it's sine or cos. It's not always like horizontal is cos, vertical is sine. This one always students have misconception, right? Okay, you can rearrange that, or like this case, right? You move this, then you complete a right angle triangle. Notice or not? Then you use trigonometry. The basic idea, the concept come from trigo, but it's a bit time consuming again, especially people who do not like maths idea, like angle, all this. Okay, so I always tell students, if the angle stick, theta stick to that component, it will be what? It will be cos. Then the other one that not stick, right? That means this theta not touching. You see this angle now is touching Fn, right? So that's why this Fw cos theta. Then the one automatically not touching will be W sine theta. Because we always resolve a given force with an angle then into the vertical and horizontal, right? But inclined plane, very special, we resolve for weight. Okay, then next, now this is resolution of 1.2, you need to know. Okay, now for the idea of equilibrium, we will focus on the plane like this one, this whole plane, right? Okay, a bit technical problem just now, sorry. So now you look at the purple idea, which means you will need to relate the FP with what? FP with F. Okay, they are opposite direction, right? You see the F is opposite direction from the plane here. So which means you can have the idea whereby FP is equals to F, or you look at the other part, which is over here there. You can also have the relationship whereby R equals to Fn. Of course, teacher find out what is your FP already, ma. So for this one, F is actually equal FPW sine theta. Then for this case, R equals to Fn, R equals to W cos. So you see which one is in the option. R equals, no. R equals to W sine theta, also no. F equals to W sine theta, right? Okay, so the answer is D. Okay, move on. We have 1.3 now, which is forces in equilibrium. Diagram 14 show a flower pot with W hanging from a pole. So the terms hanging here means any object that is hanging in air, or means in air, or like clock, fan, all this. Basically, are they moving or not? They are not moving. So this idea tell you that this object is at rest. So if it is at rest, that means they are equilibrium. They're in equilibrium idea. Okay, so which of the vector diagram present the force T1, T2, and W acting on the load correctly? Okay, so how do you do this now? So basically, what you need to do is you're going to have what? Rearrange the given force and also label all the force first lah. First step, you label the force. So for this case, right, basically there will be weight acting, which is downward W. And the two given force T1, T2 is labeled for you already. So the tension direction is always away from the object lah. I always tell students, it's like you pull your hair, you feel tension. You push your hair, you won't feel tension, right? Okay, so how do you rearrange the three given forces? Okay, so nowadays on computer very advanced, I can actually move my arrowhead here and there, right? Okay, you see, so you can actually move this up, then this one come down, or you can move this the other way, and then this one come down. Notice? Okay, so for the option of the answer, basically they actually arrange this way. This means you bring this up, then you come down. So for the vector diagram, if you notice, right, the arrowhead, they are all in the same direction, you see? They are anti-clockwise, right? So if all arrows are same direction, then the net force acting on the object is 0. The resultant force lah. Okay, resultant force. In short, we use the term net one. Okay, so for this case, now the arrangement of triangle is correct already. So the shape is either B or C, right? A and D is wrong shape one, but a lot of times students think you just draw a horizontal line across, then correct. No, no, no. Okay, then next you need to know the angle. So you see from here is 60 ma. That means the other one also 60 long. So 60 plus 60, this angle is basically how much? 120. And then you look at the arrowhead, correct or not? Yes. So the answer is B. This one, the angle is wrong. And then, yeah, the arrowhead is correct, but the angle is wrong. So you're careful with how to identify the angle as well. Okay, because in this topic, you all can actually use the scale drawing to obtain the answer. Example, they give you the weight, 10 Newton. So you can draw 10 cm, then you know the angle here. What? So you measure, you lengthen this line, intersect. Then you all can actually find what is T1 and T2 as well. Okay, so one more question for chapter 1 from 5. So this is under the idea of elasticity. So diagram 15 shows the position of a metal ball at the compressed spring before and after. Before and after the spring is released. Before and after. So distance x can be increased. So if you want the ball to move further, so what you need to do is you need to apply, what means the end result is you need to have greater what? You want this one be increased, right? You need to have greater kinetic energy, right, at the end result. So how do you get greater kinetic energy? So based on principle of conservation of energy, energy cannot be destroyed or created, but it can transform from one form to another form, right? So when you try to compress that time, what energy is stored? The gravitation, sorry, not gravitational, mistake. Okay, elastic potential energy. You will store elastic potential energy. And this energy have to be greater as well. You store. Okay, so what is the formula for this? I short form EPE is half kx squared. And then this one, you want further, right? So, and kinetic energy is m, half mv squared. You want this one higher, speed faster, right? You want convert half kx squared to half mv squared. So therefore, the spring constant, K refer to spring constant, have to be higher. There are few factors that affect the stiffness of a spring. Okay, whereby type of material, the length of the spring should be shorter, then the thickness of the wire itself should be thick, but spring diameter should be small. So this is the factor that affect the spring constant. So A, B, C is actually not accepted. And one more way to increase the spring constant is you arrange the spring in parallel, like I make it this one longer. So this is what it means by parallel. It's like you can actually withstand a higher load. Yeah, you make it even harder to compress, right, when they are in parallel. Make sense? So that's why the answer is D. Question 25 is under Form 5, Chapter 2, Pressure 2.1. The first topic, pressure in liquid. So diagram 16 shows a stone suspended on the string under the surface of the water in a beaker. The stone experienced a pressure caused by the water. What would lower the pressure on the stone? So before we proceed, there is actually slight mistake in the answer or option of the answer, because the BM version, English version is different. So for A, basically the English version is wrong lah. It's supposed to okay, dissolve, follow the BM version or some salt in the into the water lah. Okay, something like that. Okay, then the rest supposed to be same already. Okay, so as you all know, what is the formula for pressure in liquid? Pressure in liquid is H rho G, where H is depth, rho is density of the fluid, and G is acceleration due to gravity. So based on the idea, they want to lower the pressure. And if you notice all the relationship between H rho and G, they are all directly proportional to liquid pressure. So if you want to lower down the pressure, either you decrease the depth, you reduce the density of the fluid, or you actually reduce the acceleration due to gravity. So let's see A. If you dissolve some salt into the water, what happened to the density of the liquid? It become increased, right? So A is wrong. Yes, you substitute water with cooking oil. Cooking oil is lower density, correct, no? Then lower the stone into the water. If you lower the stone into the water, what happened to the depth? So depth, H. Then there will be increases, right? So again, wrong, lor. Okay, so your value of H increase, we want it to decrease, and decrease the surface area of the stone based on the formula. They didn't relate with area, so nothing to do with D. So that's why the answer is B. For question 26 is under the idea of gas pressure. Diagram 17 show a mercury filled manometer connect to a gas cylinder. Determine the gas pressure in the gas cylinder if the atmospheric pressure is 75 cm mercury. So to solve the question that involve manometer, manometer is some sort like a U-tube shape of tube. So I always tell students, if you look at the diagram, the left arm is acted by what pressure? Gas pressure. but the right arm is acted by atmospheric pressure. So why the level of liquid is not same? Because both pressure is different. If you were to look at the diagram, which pressure is higher? Is the gas pressure higher or atmospheric pressure is higher, causing the level of liquid shown in this diagram? So obviously the gas pressure have to be greater than atmospheric pressure. Okay, so to solve this question, actually you all need to draw a horizontal line across the boundary between gas and also liquid on the lower level. And the concept basically is same point, same pressure. So pressure at point 1 is supposed to be same as pressure at point 2. Point 1 is acted by what pressure? Gas pressure alone. But then point 2, you all be careful. If you look at the diagram, point 2, you have what pressure acted? You have actually a column of liquid, PL, we call, and also atmospheric pressure. So it's actually liquid pressure plus atmospheric pressure. Okay, therefore, what is your liquid pressure in terms of the length? It's not 30 cm also. What is this length? This length is 30 minus 10, 20 cm. Okay, so you just need to plus minus with the length of the liquid. The length of the liquid actually represents the idea of pressure. And atmospheric pressure is 75, and hence you get 95 cm mercury. Now, let's say y'all do know or forgot how to form this relationship. You always remember, if you more, this means you added the difference in the length of the manometer. If the gas pressure is less, then you minus, using atmospheric pressure minus, then you will always get the answer. Okay, then question 27. Diagram 18 show a hydraulic lift in a car repair workshop. It is given that the force exerted on the piston A to lift the car and the car support is 2000 Newton. Determine the total weight of the base support and the car. Okay, so for the idea of this is under Pascal principle topic, or still under chapter 2 pressure. Okay, so what you all need to do is you all will apply the concept on this Pascal principle, where pressure is the same, and hence you will have F1 over A1 equals to F2 over A2 idea. Okay, so given this force exert on piston A is the smaller piston, then they give you the given force. That means this is F1 and this is A1. Oh, you all need to label correctly. Which one is A, which one is 1, which one is 2. And wow, sorry, this A is, yes, A1. Then the 4 piston area of each piston 0.02, then they become A2 lor. And they basically want you to find the total weight lah. But before you find the total weight, you need to know each base support how much first ma, which means you find out F2. Or F2 is unknown. Okay, then now we sub the value inside. Okay, 2000 over 0.01 equals to F2 over A2 0.02. Then you calculator, press, you will get the answer. F2 is 4000 Newton. But F2 is not the answer yet, because this F2 is only for one base. We want to have what? Total weight of the base support. So there's how many base? 1, 2, 3, 4. So your end result is the total weight of support, right? Will be 4 times 2000. 4 times 4000. Then you will get the answer as B, 16,000 Newton. Okay, so basically this question is quite direct. It's just that you all need to be careful lah, because most of the time they may only give you 1 piston instead of, like this case, 4 pistons. So you all need to read the questions carefully, or else you all may make mistake. Okay, then moving on, 28. 28 is under Archimedes principle. 4 identical submarines, P, Q, R, and S, are lowered from one depth to another in water of a constant density. The liquid have the same density, and the initial and final depth of each submarine is shown in this diagram. So, which submarine experience the same change in pressure? So, you all need to understand what is mean by this change in pressure. So this change in pressure is actually the liquid pressure. They are submerged in the liquid. They also link a bit on the liquid pressure idea. If you would to have the same change in pressure, you see pressure idea is H rho G. So G in this contact, rho in this contact, they are constant. So that means they are affected by what? The depth, the depth. Okay, therefore, we find out what is the difference first. So for P, the difference here is 20 meter. This one, Q is also 20 meter. R to R point to here is actually how many meter? 50 minus 10, you get 40 meter. This one is also 40 meter. So if they were to experience the same change, that means their depth supposed to be same. Okay, I repeat again, if they were to experience the same change, then the difference in depth should be the same. So that's why P and Q actually experience the same change, or R and S. So, but the given option, okay, P and R wrong, P and Q yes, Q and R wrong, Q and S wrong. They do not have R and S, so the answer is B lah. Okay, then move on. Question 29. Now we are entering the electricity topic. And on 3.1, the concept of electric current and also potential difference. So diagram show a circuit with two measuring instruments X and Y connected correctly. What is the unit measured by both instruments? Okay, so first we need to know the arrangement. If they're always arranged in parallel, so this is a parallel arrangement. That means you have another connecting wire, you connect across the load. This is a resistor lah. And then this one is a dry cell, right? So you connect across in parallel. So basically for X, you are measuring the voltage, the idea, the EMF. If the circuit is open up, is closed, then it become voltage. Similarly, Y, you in parallel. So you are measuring the idea of voltage or potential difference. They are same thing. Hence, they should have the same unit, which is volt. If they would to be a ampere, right? That means current they only what means you arrange the ammeter in series with the circuit, then they may have possible answer as ampere. So that's why now the ammeter is not in series, so there's no option for this one. Number 30, a student use a length of wire as a resistor. To decrease the resistance, he need wire that is. So this is under the concept of factor affecting resistance for topic 3.2 resistance. Yeah. So the four factors is what? Length. Okay, and then cross-sectional area of thickness of wire. Okay, then temperature and also type of material. Okay, so based on the option given, we will only focus on these two factors. So if you want the resistance to be less, what happened to the length? The length have to be shorter. But in terms of the idea of thickness or cross-sectional area, it should be bigger. I always tell students, you have a bigger tunnel and a smaller tunnel. Which one is easier for you to move across? Of course, the bigger one, right? Okay, because more empty space, the smaller one, you may stuck somewhere already. Yes, so that's why the idea of cross-sectional area, when the area is big, the resistance is low. Okay, so we see which option have lah. Longer, cannot already longer. Shorter, yes. Then thickness, they have to be thicker. So the option is C, because it cannot be thinner. 31. Which of the following electric component produce an electromotive force? So as you all know, under the topic for EMF and also internal resistance. So this electromotive force is actually referred to the power source, right? So that's why the answer is dry cell law, because the rest is not the idea that produce the energy for the complete circuit. Then the 3.2. Now we're entering chapter 4, electromagnetism. For 4.1 is the idea of how a force is produced, but in the basic idea, you're supposed to know if there is current flow through a straight conductor, they will act like an electromagnet. Therefore, electromagnetic field is produced. So for this context, the field produced is circular, and you need to know the direction of field. So you will use what? Right hand grip rule to get the concept. Okay, so don't use the wrong hand. So what is this right hand grip rule? Thumb is what? Thumb is direction of current. And then the curved finger is the field. Curved fingers is the magnetic field direction. Okay, so now your current is up, right? So your thumb pointing up, then you look on the top view, you look from here. What happened to your curved finger? They move in anti-clockwise, right? Okay, so the compass will follow the field direction. So you see the compass nearby this side is going up. Now, let's say teacher have other compass as well that located on circulating lah. Here also got compass, here also got compass, here also got compass. So they really will follow the direction of the field. That means it will point like this, point like this, point like this. So our answer compass is located here. This is on 3-dimensional. So this is on 2-dimensional. Dot means the current point out. Same thing. What this means now? Just now, this one I show you up. So in this case, they are same. This is like top view. So you view it as 2D. So dot means up. Dot, you all need to know dot. Another one, they will show cross one. Cross means into the screen. So dot, so again, you see, you are anti-clockwise. When you point, dot means up from the screen. Out from screen or paper if you are doing in a paper now for this exercise, right? So again, you will have up. So the answer is B. Can okay. Then moving on. This one is under 4.2 for electromagnetic induction. Induced current flow in such its opposite direction that is produced. So this is memang a general idea lah. You're supposed to know this concept why it's always opposite direction. Produce it is actually from Lenz's law, whereby you need to use it to determine the polarity of a solenoid, giving you a galvanometer with solenoid. So you need to know what is this pole when the magnet is moved in or out. Okay, so to determine the polarity of solenoid, we use Lenz's law. Then 34. So this is under the chapter 4, transformer from 5. So which of the following statement is true about the transformer? Okay, so left side, this is primary coil. Okay, the one that coil on the left side. Then this is secondary coil. So if you notice the number, this is NP log. Okay, this is NS. So NP is more than NS, or NS is less. That means this is step down transformer, step down. Okay, so this 2 is wrong. Okay, then how do you calculate why the we can link it is because they're related to voltage, right? So we have this formula under transformer. Vp over MP equals to Vs over Ms. Okay, so we want to find what is the secondary voltage. The voltage across the mantle is Vs. We want to find this Vs. Well, this is Vp. So now we sub the answer to get Vs. So Vs is basically Vp 240, MP 400, and then we times this one. Okay, 80. And if you press calculator, you're supposed to get 48 volts. Okay, so therefore, the answer is D. Now we move on to question 35. The release of electrons from a surface of matter when it heated is known as what? Okay, when you heat up the matter, it will release electrons. So this concept is called thermionic emission. Thermionic emission under the topic for electrons. Chapter 5, electronic in form 5. Then chapter 5, 5.2 regarding semiconductor diode. So this symbol is actually diode. What is the function of diode? Allow current to flow in one direction. Okay, so giving you a simple diode, it will only flow current provided your terminal, the current flow from positive to negative, like this. Actually a diode, you have this part, we call it at N type and P type. Okay, so the line one is N type, P type. If you connect positive to positive and to negative, then this is called forward bias connection. Forward bias. That means the current can flow. If I able to have complete circuit, then they will flow. But if you to reverse the direction of the diode, means now still same circuit, but I put like that, my battery don't change lah. Then this is N, right? But this is positive, this is P, this is negative. Then no current can flow. So no current. In this circuit, no current. And then we call this as what? Reverse bias. Okay, so in this case, positive, and then this is P, right? And can flow or not current? Yes, so they can allow current to flow if the switch is closed. But for this arrangement of diode, right, this is still N, or this is P. So positive and N, can current flow or not? Cannot, no? So that's why Q cannot light up, lor. Only P able to light up. Okay, so P light up, Q light off. Okay, so see ya. Okay. Then we have 37. 37 is under the concept of transistor. Which of the following statement is true? And this is the circuit that they actually use the concept of automatic switch, whereby the function of thermistor, they are actually sensitive to heat, and they're suitable to be used to automatically detect whether there is a fire or not, as in this fire alarm system. So what is the characteristic of this thermistor? We always relate those electronic component. You have another component called LDR with the resistance in certain conditions. So for thermistor, you all need to have this basic idea. The resistance of this thermistor, short form resistance of thermistor, will be actually high when the surrounding temperature is cold. If the thermistor resistance is low, that means the surrounding is actually hot lah, or high temperature lah. Okay, so this is a basic idea. And for the transistor circuit to work, right, you also need to, in general, really know about the circuit. So this part is called base circuit. This is collector circuit. And in the transistor topic, you need to be very particularly about the collector current, base voltage. So the voltage across here is called base voltage. Okay, and the relationship, the base and the circuit on top, they memang do not have a specific name lah. We just say the circuit on top. They have a inverse relationship, which means if the resistance on top high, bottom will be low, or vice versa. So for this case, first, what type of transistor is this? Okay, the current flow this way. So current flow from positive to negative, therefore NPN. Oh, correct. So will the alarm be turned on in cold conditions? So let's predict the idea. So because your thermistor placed on top, during cold, now your thermistor is here, cold. Resistance how? High. Then teacher actually mentioned if the resistance on top is high, that means the bottom will be low. So if the base part, right, the resistance become low, right, that means your base voltage will be also low. If base voltage lower, the current will be low one. everything will not be function. So by right, it will turn off. So wrong. Okay, then move on again. The voltage across 10 kilo ohm resistor will increase in hot condition. So in hot condition, the resistance up is low now it's not this already. So the top one is now hot. Resistance on top is low. That means the bottom will be how? High, correct? So therefore base voltage will be reversal. This one is another scenario already. Base voltage, high current can flow. So base voltage, so hot, yes, the voltage is high, increase. So that is correct. The resistance increase linearly to the temperature, or some sort. The idea is when temperature increase, the resistance increase. So I show you already. Correct or not? Hot, no ma. So wrong. So that's why the answer is option 1 and 3. Number 38. Which of the following is a fission reaction? So fission is what? What is the meaning of fission under nuclear energy? This topic of fission is the splitting of heavy nucleus to two or more lighter nuclei. Like nuclei. Sorry, nuclei. Okay. When hit by a neutron, when hit by a neutron. Okay. So basically, what is the correct one? Okay, so you have uranium becomes strontium and xenium. At the same time, they will release 3 more neutron. N is neutron. Okay, A is nuclear fusion, not fusion. That means you combine opposite of fusion. And B and C, you have alpha, beta, right? So you have alpha decay, beta decay. These two is decay curve, decay equation. So also not the option. Then 39, we entering the last chapter already on quantum physics. Calculate the power of the red light lamp which emitted 1.76 times 10 power 20 number of photons per second. Then wavelength is 7 times 10 power negative 7 meter, and giving you the Planck constant 6.63 times 10 power negative 34 joule second. So for this topic, of course, you all need to know what is the formula that related to power. So in general, energy is Planck constant time frequency, and then power is actually NHF, where this N is the number of photons. Okay, so given questions, you have what number of photons right here. Okay, they give you wavelength and they give you Planck constant. So my equation do not have wavelength because we can have another formula that relate frequency and wavelength, which is C equals to F lambda. So you can always change the equation slightly because the speed of light is always constant. Hence, you will have F equals to C over lambda. So hence, my final formula is NHC over lambda. Okay, so now you can sub the value inside already. The N is 1.76 times 10 power 20. The Planck constant is 6.63 times 10 power negative 34. And the speed of light, if they didn't give you in the questions, right, you'll go to the formula list. Normally, they will have it in the formula list one because it's a constant value. And then the wavelength is in meter. No need to change as well the unit. So straight away 7 times 10 power negative 7. Then finally, when you press calculator, you supposedly will get about 50 point something or what. Yeah, so you all need to know the formula, then you can apply the formula in these questions. Okay, so for the last questions, is under the idea of photoelectric effect, the applications itself. Okay, so what is this photoelectric effect? It's actually what? when a metal surface, this is metal, okay, being illuminated, that means you shine a light, but it must be contain light energy. Light energy, you all need to know two concepts. Light can be in terms of particles or wave. The concept, so light in terms of particle, we call it as photon as well. So light wave, you all learn in Form 4 wave topic, like all the electromagnetic wave. Under electromagnetic wave, we have light wave, correct now. So when you hit this or illuminated on the metal, then you will have the photoelectron being emitted out. So this is called photoelectric effect. Photoelectric effect. And we make use of this photoelectric effect in solar panel, in also in the idea of this laser pointer. But for Polaroid camera and also endoscope, right, they still make use of light idea, but then they are light in wave. So that's why they're not so proper, and your answer hence is A lah. Okay, therefore we actually complete the whole state paper for Selangor 2021 set 2 paper. Hopefully all the explanation is useful for all of you, and you'll have a better understanding for all the topic. So that's it for the explanation for the state paper. Thank you.